right. All right, guys. All right, guys, we're looking at one of the homework problems from yesterday. So we're looking at this complex fraction. We need to simplify it. Now, the least common denominator between the denominators in the numerator and denominator, we have 3 and x. So we're going to multiply the whole thing by 3x. So 3x times our x over 3 is going to be 3x squared over 3 minus 18x. We'll do the same thing on bottom. 3x times 10 is going to be 30x. 3x times 4 over x is going to be plus 12x over x. Now we simplify this down because our 3x squared over 3 is going to be x squared minus 18x. On bottom, we still have the 30x, but 12x over x is going to be 12. Now we need to see if there's anything in common on top and bottom, if anything will reduce. And to do that, we need to factor. So if we look at the top two terms, x squared and 18x, is there a greatest common factor between those two terms? X. And if we factor an x out of x squared, we get x. And if we factor the x out of 18, we have 18. So it's x times x minus 18. Now that's simplified, partly because there is no like terms inside the parentheses, or x and 18. And the degree is 1. The variable exponent's 1. So that is simplified as it gets. 30x plus 12 has a greatest common factor of 6. And if we factor the 6 out of 30x and 12, we get 5x plus 2. Now the degree with our 5x plus 2 is also 1. There is no other like terms, so that's factored. Well, the x minus 18 and 5x plus 2 don't match up, so they won't simplify. Outside the x and 6, do they have any like terms? No. That's as far as we can go. We got it as a single term. We can't reduce anything. That's it. Questions on this here? Most of the ones on 742 aren't going to reduce, but we do want them in factored form just to make sure they don't. Questions on this here? $42? Mm-hmm. All right. We ready to look at 42? 42. Now, our least common denominator that we're going to multiply everything by has 3 terms. One of our terms is going to be, well, just x. Then we'll have exactly x plus 1 and x minus 2. This one indeed does have 3 different terms for the least common denominator. So that's because each of the denominators are something different. So if we multiply this through, on top we'd have 16x times x plus 1 times x minus 2 all over x minus 2. On bottom, we have the 4 times x plus 1 times x minus 2 all over x plus 1 plus 6 times our x times x plus 1 times x minus 2 over x. Questions on this here? Question on anything so far with this? Now we're going to simplify. Now the x minus 2 on top and bottom of the top fraction will cancel out, leaving us with 16x times x plus 1. On bottom, on the one on the left, the x plus 1 and x plus 1 will cancel, giving us 4x times x minus 2. Plus, here the x and x will cancel, giving us 6 times x plus 1 times x minus 2. Questions on how we got to this point here? Now this will actually answer a question, or kind of verify what I was showing you earlier. If we look at the numerator, 16x times x plus 1, yes? Is there anything up there that we could possibly have like terms with, stuff that can combine? Are we adding anything together besides that term? Well, it's kind of hard to see. Let's look at the bottom. Do I have things being added together? Yeah, we have the 4x and x minus 2, and we're adding to it another term, the 6 times x plus 1 times x minus 2. Is there a possibility there might be some like terms there? Yeah, there's going to be some stuff we're adding, subtracting. There, I'm going to have to simplify because we're not done. There's other stuff that could happen. On top, is there any other stuff we're needing to add, subtract, do with it? No, it's a single term now. It's those two together. We could multiply the 16x by our x and then the 16x times our 1. But if there's something that's going to simplify out, I'm going to have to then factor it back to 16x times x plus 1. It's already factored as one term. We don't have to go back. Does that make sense? Because on bottom, there's a chance that there might be some like terms here. Now, there is a cheap or an easy way to get to this. It is a little weird, but we'll go on multiply through. Yeah. On the left, this here, we'd have 4x times x, which is 4x squared. 4x times negative 2 is negative 8x. Plus 6. We'll multiply through our x plus 1 and x minus 2. X times x is going to be x squared. X times negative 2 is negative 2x. 1 times x is positive x. And 1 times negative 2 is negative 2. Combined like terms are negative 2x plus x is going to be negative x. Now we're going to have to distribute that 6 through, giving us 6x squared minus 6x minus 12. Combine like terms, 10x squared minus 14x minus 12. Questions on this so far? Is there a greatest common factor on bottom? Greatest common factor of 2. Okay. So we'll have 2. 5x squared minus 7x minus 6. Okay. All right, let's make this a little bit nicer. 16 over 2 is what? Because we can see the 16 over 2 is going to reduce eventually, yes? 16 is going to reduce to 8. And the 2 on bottom is now gone. 5x squared minus 7x plus 6. Our signs are going to be opposite because the third term's negative. Factors of x squared are x and x. I'm going to put the 5 with the plus and 1. Factors of 6 1 and 6 or 3 and 2. Now this is going to work because 5x times negative 2 would get us negative 10. 3 times x would give us plus 3x. Negative 10 plus 3 is negative 7. Is there something in common on top and bottom at this point? That's it. Now the reason we can stop here is the denominator is as simplified as it gets. The only thing we could really do with it is either split it up so that we have two different fractions with either 8 on top, x plus 1 on top, or 5x plus 3 on one of the bottoms, x minus 2. Or we can multiply back out. But if we multiply that back out, we just get back here. We start going backwards. Does that make sense? And really with simplifying, especially addition and subtraction, don't start simplifying or crossing things out on top and bottom until we've gotten it as one fraction, all the numerators together, all the denominators together, and factor. Does that make sense? Yeah, no. If you have questions on these here, especially addition, subtraction, multiplication, ask. All right. What we're doing today is we are starting solving rational equations. We're going to start solving rational equations. Now, the first thing that we're going to do with these rational equations, it won't come up much today. Restrictions. And the restrictions are any value of x that would make a denominator, one or more of the denominators, be 0. Because if one or more of the denominators become...
Madison Hancock, please come to the office. Madison Hancock, please come to the office.
Because if one or more of the denominators become 0, then we're dividing by 0. It doesn't work. So if we look at these here, x plus 1, we can solve this here, telling us that if x is equal to negative 1, we'd have a denominator of 0, so it doesn't work. It's a restriction. For our 4x plus 5, the first thing we can do is subtract 5 from both sides, telling us 4x is equal to negative 5. Then we can divide by 4, telling us that if x is equal to negative 5/4, we'd have a division of 0, and that would not work either. And this is kind of nice because this prevents us, or not prevents us, but helps us not have to plug in all of our answers back into the original equation to make sure they work. Because if negative 1 or negative 5/4 shows up, it's a restriction, it's an extraneous solution, it's not going to work. So we don't even have to plug them in to know that they don't work. Does that make sense? Now, next step. Questions on the restrictions. We've done those before. Next part, least common denominator. So we want to look at these two here and see if we can find the least common denominator. X plus 1 is as factored as it gets. 4x plus 5 is as factored as it gets. So it's one of the terms for our least common denominator. X plus 1. What else? 4x plus 5. And we're going to be using this here. Okay. Now up to this point, whenever we've done anything with the least common denominator, applied it, we've always been multiplying on top and bottom, on top and bottom, on top and bottom. Yes? Because we've taken the least common denominator yesterday, we had multiplied the fraction by x plus 1 times 4x plus 5 over x plus 1 times 4x plus 5. Multiplied it by something over itself. And the reason we had to do
Jason
that...
Brown, please come to the office. Jason Brown, please come to the office.
Is because we had an expression. When we multiply something by something over itself, anything over itself, we're just multiplying it by 1. We're not changing the value. Here, we don't have an expression, we have an equation. We have stuff on both sides, which means it gives me the freedom to take this least common denominator and just multiply the entire expression, every term in it, by the x plus 1 times 4x plus 5. I don't have to do it on top and bottom. We're just going straight across. Because what we're doing and what we're using here is something called a scalar. We're scaling the problem up. Because normally we would talk about a scalar as a number, but it can be an expression. And it's going to do something very interesting. Because for the fraction on the left, we'll have 3 times x plus 1 times 4x plus 5 over x plus 1. On the right, we're going to have 9 times x plus 1 times 4x plus 5 over x plus 5. And again, we're just multiplying through the top. Multiplying through the top because I'm just multiplying that 3 over x plus 1 by these two terms here, which are technically over 1. Now the left side, the x plus 1 and x plus 1 will cancel, leaving us with 3 times 4x plus 5 is equal to, on the left-hand side, 4x plus 5, 4x plus 5 cancel, leaving us with 9 times x plus 1. And we'll have to do some more here in a minute, but questions on how we got to this point. So the whole point of using the least common denominator was to get rid of the fractions. Now we have this polynomial expression, polynomial equation we can solve. On the left-hand side, we can distribute the 3. 3 times 4x is 12x. 3 times 5 is plus 15 is equal to 9 times x. And 9 times 1 is 9. Yep, plus 9. Do we have a variable with an exponent bigger than 1? No, we don't have x squared, x cubed, x to the 4th. We just have x, yes? Get x by itself. We're just solving for x. So it's been a while since we've had an equation like this. Isn't this nice? What can we do first? Subtract 15. Telling us 12x is equal to 9x minus 6. Are the x's together? So what can we do? We can minus 9x. 12x minus 9x is 3x equals negative 6. So we divide by 3. X is equal to negative 2. Questions on this so far? That's it for this one here. Because I mean, if we could have x squared, it's just at that point solving quadratic or higher degrees. The big thing is getting those fractions gone, getting rid of them first. Because if we can get rid of them, then it's going to make this a little bit nicer. Get ready for the next one. Restrictions. X plus 2, we would subtract 2, telling us x cannot be negative 2. Subtract 2, telling us 3x equals negative 2. Divide by 3, telling us that if x is negative 2/3, we'd have a denominator of 0. That doesn't work. So really, x cannot be negative 2 or negative 2/3. Now, what would happen if we got one of those values? Well, put a big old X through it. It doesn't work. Because again, if we solved this and it said x equaled negative 2 for this one also, well, negative 2 is going to make the denominator on the left be 0. X cannot be negative 2. So we throw that solution out. It's an extraneous solution. It's a value that works in solving it by our mathematical steps. It is a solution, but in the context of the original problem, it doesn't make sense. It doesn't work. Because it works out that way. That just some of the answers are when we solve it, it does give us an answer, but it just doesn't make sense in what we started with. Least common denominator. What do we know we're going to need to multiply through by? X what? X plus 2, yes? Because x plus 2 does show up in one of them. The 3x plus 2 is as simplified as it gets. Because the main thing we're focused on is that we don't use one term more than once, more than is needed. Because if I start off with x plus 2 and multiply through by x plus 2, on the left-hand side, the x plus 2 and x plus 2 will simplify. We saw that in the last one. When we multiply through by it, it's going to be divided by itself, so it's gone. Yes? What else do we need? Because on the right-hand side, the 3x plus 2 and 3x plus 2 will cancel. Our least common denominator is x plus 2 times 3x plus 2. And let's see what that leaves us with. On the left-hand side, we have 2 times 3x plus 2 is equal to 10 times x plus 2. Here we can distribute the 2. 2 times 3x is 6x. 2 times 2 is 4. 10 times x is 10x, and 10 times 2 is 20. What can we do next? Yeah. And really what we do first at this point is actually 4 different options that we have available to us. Because one of them is subtracting 4. The other, we could have subtracted 20. Or we could have subtracted 6x or subtracted 10x. We could have done any of those 4. But once we do one, it kind of restricts us on what we have to do next. Now we need to subtract 10x. Because again, since we do not have an x to a power greater than 1, all we got to do is get the x by itself. Minus negative 4x is equal to 16. At this point, we can divide by negative 4, telling us x is negative 4. Questions on this here? No. We're good with this one here. Okay. So we found the answer is negative 4, and then I doubt this ever happens, but sometimes you get an answer and you're not sure if it is the right answer. It seems like it's too weird of a number, yes? There's an easy way, and especially with solving that's nice, is I can take that value and I'm going to plug it into the left-hand side. Now this is a number. A calculator can do this for us. Negative 4 plus 2 is negative 2. 2 divided by negative 2 is? Okay, so the right-hand side became negative 1 when x was negative 4. let's go to the left-hand side. The right-hand side, 10 over 3 times negative 4 plus 2. 3 times negative 4 is negative 12. Negative 12 plus 2 is negative 10, telling us what the right-hand side is negative 1. Is the left-hand side and the right-hand side equal? So that tells us that negative 4 is a solution. It doesn't matter what the left and right-hand sides are. It could be that you plug it in and find out, I'm just going to make stuff up, square root of 7 over 4. Square root of 7 over 4 is not a nice number, but as long as both sides are the same number, that's a true statement, yes? So that means it is a solution. So it's a way that we can check it. We can plug it back in and make sure that the left-hand side and the right-hand side are the same. If they are, it's a solution. It works. If it's not, then it's not. Restrictions. So the two places where x can be 0 are at 5x and x minus 7, yes? 5x. So we're saying 5 times x would give us 0. What's the only number that x could possibly be? We're multiplying 5 by a number and somehow getting 0, yes? That's the only number I can multiply 5 by and get 0. So here, x cannot be 0. 0 product property. If you multiply 2 or more things together and get 0, one of them has to be 0. X minus 7 equals 0. What can we subtract from 7? Or what number minus 7 is 0? 7 minus 7 is 0, yes? Yeah. Or we could add 7 to both sides and see that x is 7, yes? All right. So those are restrictions. X can't be 0 or 7. Now we do have another nice one because 5x is factored. X minus 7 is already factored for us. Nothing we can do to it. So what do we need to multiply both sides by? 5x. Because on the left-hand side, the 5x and 5x here will cancel. Anything else? X minus 7. Because on the right, x minus 7 and x minus 7 will cancel, leaving us with 3 times x minus 7 is equal to 10x. Three times x is 3x. 3 times negative 7 is negative 21. Yes. We can subtract 3x from both sides, telling us that 7x is equal to negative 21. At this point here, we can divide by 7, telling us x is negative 3. Now, we could have added 21 to both sides, but then we would subtract 10x, then work it from there. So it's, I think, if it would work, it'd still work. It would just take more steps because we'd have to move our constant term, move the variable, and then divide. Might be easier just move the variable and divide. Questions on this so far? Negative 4 over x plus 3 is equal to 5 over x minus 3. So really, it's saying for our restrictions that x plus 3 can't be 0 and x minus 3 can't be 0. Those are our two denominators. They are factors, so there's nothing else we can do with it. But here, it's really just telling us that x cannot be negative 3 or positive 3. So if we get positive 3 or negative 3, that's an extraneous solution. We have to throw it out. What are we going to multiply everything by? X plus 3 and x minus 3. And since the x plus 3 and x minus 3 only showed up once in each of the different denominators, we only need it once. X plus 3, x plus 3. X minus 3, x minus 3. Leaving us with negative 4 times x minus 3 is equal to 5 times x plus 3. Here we're going to distribute the 4. Negative 4x plus 12 is equal to 5x plus 15. Questions on this here? What can we do first? You're on the right direction. Subtract 12. No, you're good. I think you... But what we could have done also is we could have added 4x. But here, I would now subtract the 5x, say negative 9x is equal to 3. And lastly, we would divide both sides by negative 9, which will tell us that we have x is equal to negative 1/3. Which is not one of our restrictions, so that is our solution. Questions on this here? Let's do one more, then we'll save the rest for Monday. I'll tell you right now, x cannot be negative 5 halves or negative 8 elevenths. Negative 5 halves or negative 8 elevenths. If it's either one of these here, no solution. Because really the denominators, 2x plus 5, we would subtract 5, divide by 2. 11x plus 8, we would subtract 8, divide by 11. Least, well, 2x plus 5, no greatest common factor, we can't factor it. 11x plus 8, again, no greatest common factor, we can't factor it. So I am going to have to multiply both sides by 2x plus 5 and 11x plus 8. On the left-hand side, 2x plus 5, 2x plus 5. 11x plus 8, 11x plus 8. So when we multiply through, we have 11x plus 8 is equal to x times 2x plus 5. 11x plus 8, there's no like terms, there's no parentheses to distribute, so we're good there. Other side, we'll distribute our x, giving us 2x squared plus 5x. Since we don't have a power greater than 1, we can get x on one side and everything else on the other, yes? What do we have this time? We have x squared, yes? So it is a quadratic equation. Anytime we get variables where the power is greater than 1, we got to get this equal to 0. The only exception is if we don't have an x term, we don't have a middle term, our square root method. When you get x squared equals everything else, take the square root of both sides and simplify. So just to make sure that the x terms don't cancel, let's subtract 11x from both sides. If we do that, we have 8 is equal to 2x squared minus 6x. Okay, we are indeed going to have to get this equal to 0. Because if that middle term, that x, had canceled out completely, we were just left with a number in x squared, can sometimes make it a little bit nicer. minus 8 from both sides, telling us that 0 is equal to 2x squared minus 6x minus 8. Yes. Now, what is interesting is greatest common factors with solving. I think we've talked about this when we talked about quadratics or higher degree polynomial functions. Is there a greatest common factor between these three terms? It is 2. Now, if it's a number, we can divide the whole thing by it. If it's a variable, we cannot. If it's a variable, we cannot. Because again, our variables are representing solutions to this equation, values of x that will make the function be 0. So if I divide by 0 or divide by x, or that variable, I've taken one of the solutions and removed it. Here, we're scaling it down. We're removing that 2. Now, I'm going to show you another reason why this works. Because if we factor that 2 out, I get 2 times x squared minus 6x minus 8. Nope. I do not. Yes. 3x minus 4. I factored it out of the first term and then left everything the same. I know, that's a shame. But what do we have here? I have 2 times our parentheses, yes? We have 2 things being multiplied together, yes? And if we have 2 things that are being multiplied together that equals 0, one of them must be what? 0. Is there any way I can make that 2 be 0? I mean, no, it's just 2. There is no variable. There's no number we can plug in. It's just 2. So out of those 2 expressions here, the only thing that can actually be 0 is what? The x squared minus 3x minus 4, yes? So that's why I can say here, I divide both sides by 2. Those cancel. I can get rid of that greatest common factor of 2. Because that's only going to leave me with x squared minus 3x minus 4. All right, Everett, what's 0 divided by 2? Yeah. Because if we do that with a variable, that variable's gone on the left side, or the right-hand side here. And on the left-hand side, 0 divided, or x divided by 0, or sorry, 0 divided by x is just 0. That's gone completely. We've lost a solution. And normally it does end up being 0. Four is negative, so our signs are opposite, x and x. Factors of 4 are 1 and 4 or 2 and 2. 2 and 2 is not going to work. Because if we did 2 and 2, we'd have what? X plus 2 and x. Well, x plus 2 times x minus 2 is our difference of perfect squares, which means we wouldn't have a middle term. Do we have a middle term? Yeah. So it's probably going to be 1 and 4. And this is the correct set of factors. Again, like we said already, we have 2 things multiplied together equals 0, so one of these must be 0. So either x plus 1 is 0, or x minus 4 is 0. So either x is equal to negative 1, or x is equal to 4. Is either one of those one of our restrictions? No. So our 2 solutions are negative 1 and 4. So 2x squared minus 6x minus 8. I could have graphed it. We have our solutions. Now the one we ended up solving was not this here. We solved x squared minus 3x minus 4, yes? At -1, both of the y values are 0. At 4, both of the y values are still 0. So taking that greatest common factor of 2 out, that scalar of 2, does change every other point of the graph except for where it crosses the x-axis. Those stay the same. Ready for this one here? Well, it's got to wait.